All right, let's do a little brainstorm on logarithms. So let's say we have a log base 5 of 125. Okay, well, we know that this is asking us 5 to what power equals 125. Now you probably already have figured that out. 125 is 5 times 5, which is 25 times 5. So this is 5 to the power of 3. Okay, so the log of 125 to the base 5 is equal to 3. All right, so what happens instead of 125? Let's say I multiply 125 by 25. Okay, well now this number is bigger, so it's going to take more 5s to make that full number. Well, how many more? All right, let's see. 5 to the what gives us 125 times 25. Well, 125 is 5 times 5 times 5. 25 is 5 times 5, so it looks like a total of 5. It's 5 to the power of 5 equals 125 times 5. So the log of 125 times 25, base 5, is just equal to 5. There are 5 of them. All right, let's say I multiply it again. So log base 5 of 125 times 25 times 625. Well, what's that going to equal? All right, pause the video if you want to guess before I reveal it. But this is just basically the log base 5 of, well, 125 is 5 times 5 times 5. 25 is another 5 times 5. And 625 is another 5 times 5 times 5 times 5. And so this is log of the base 5 of 5 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so power of 9, and so that just equals 9. All right, now if you noticed, the log with a base 5 of 125 is equal to 3, because the log of 25 with a base 5 is equal to 2. And the log of 625 of base 5 is equal to 4. How did we get 9? What did we have to do to the 3, the 2, and the 4? Okay, well, obviously we had to add them. So when I have the log base 5 of some value, 25, and that equals 3, and the log base 5 of another value, 25, and that equals 2, and the log base 5 of 625, and that equals 4. What happens when I take the log base 5 of 125 times 25 when I start multiplying these together? Well, that's just going to equal the log, so we got all three of these in the log. It's going to equal the log base 5 of 125 plus the log base 5 of 25 plus the log base 5 of 625. Okay, some people get surprised by this because we're actually adding them together when these guys get multiplied. But it makes sense as well, right? Because when you're multiplying more, well, that's just this number that the log equals, right? So this is just 9. It's just the number of times that you have to multiply by 5. So it makes sense that you'd be adding it together, because at first you have to multiply by 5 3 times, and then you multiply by 5 2 more times for a total of 5. Then you multiply by 5 4 more times for a total of 9. So that's how many times you multiply by 5. So this is what we call the product law of logarithms. If you have a logarithm to any base of different values that are multiplied together, let's say x, y, and z, well then that will be the same as the logarithm of that same base of the first one plus the logarithm of that base of the second one plus the logarithm of that base of third one, and so on and so forth. I believe in any textbook it will just stick to 2. It'll just say the logarithm of any base of 2 values multiplied by each other are the log of the first one to that base plus the log of the second one to that base. But you could go on, you could do 3, 4, 5, whatever you need. So what would you do if I gave you a log, let's say any base, so let's say the base 6 of 54 to the power of 9. Well, hopefully you would notice that the log base 6 of 54 to the power of 9 is just equal to the log base 6 of 54 times 54 times 54 times 54 times 54, 9 times. And then you would say to yourself, well, the product law of logarithms tells me that that's just going to be equal to the log base 6 of 54 plus the log base 6 of 54 plus the log base 6 of 54, and so on and so forth, 9 times. Okay, well then couldn't we just say, since it's repeated addition, couldn't we just say that this is 9 times the log base 6 of 54? Yes, we can. Right? So that is another law. This is called the power law of logarithms. If you have a logarithm to any base of a value that's raised to the power of something, of anything, then you could just rewrite this as whatever that power was times the log of that same base of your original value. So that's now the power law of logarithms. Okay, we know the power law of logarithms, the product law of logarithms. The last one is the quotient law of logarithms. Let's say we had a log, let's do base 5, because I know those powers pretty well, of 625 divided by 25. Okay, well, how would we go about that? Let's see. We know that this is equal to the log base 5 of 5 times 5 times 5 times 5, which is 625, divided by 5 times 5. All right? Well, the log of base 5 of 625 is 4, because we have 4 at the top here. And we know that the log base 5 of 25 is 2, right here. That's a 2, because there are 2 down there. And the log base 5 of 625 divided by 25, well, 2 of these are going to cancel out. There's just going to be 2. So really, we could just use the log of the same base of the top one, and we'll know you get the total number of those, that's 4. And then you just subtract the log with the same base of the bottom one, because that's the number of them they're going to be canceling out from the top. Right? So instead of 4, we've canceled out 2 of them, so we're only left with 2. Right? That's almost the same thing as the product law of logarithms, where if you have a log with any base of 2 numbers that are multiplied by each other, that's just going to be the log with that base of the first one plus the log with that base of the second one. So obviously, if you have a log with a certain base of 2 numbers where one is divided by the other, it's going to be the log without base of the top one, subtract the log of that base of the bottom one. So there you have it. That is the quotient law of logarithms. And now we know the power law of logarithms, the product law of logarithms, and the quotient law of logarithms.